I'm Usama Hassan and I'm physics teacher in Pamir private school. As you know that due to the coronavirus, all the schools of UE have been closed, and so our school has decided to enrich our students and to prepare them for the board exam. They have decided to initiate e-learning and online video lectures to provide them, to prepare them for the board exams. Today I am going to discuss about a very important question related to class 9 chapter number 6, kinetic energy and its derivation. So this question, you can see that in the past few years it has been asked many times. So this question can be asked in both ways, either in short question or long question. So if it will be asked in short question, you have to give its brief introduction, example and unit. That's it, you will get 3 marks. And if it will be asked in a long question, you will be asked to derive it. So this question could be asked in a long question in such a way that define kinetic energy and derive its relation. So today we are going to do this topic. So first of all, in every topic you need to define the topic. So we will define it, we will give its definition according to the board's marking scheme. So first of all, you need to define it. Let's see its definition. The energy possessed by a body due to its motion is called kinetic energy. It is denoted by kinetic energy and its unit is joule. So what does it mean, motion? Motion means whenever the body is moving, whenever the body has velocity, it must have kinetic energy. As you know that kinetic energy is a type of mechanical energy. We have mainly 2 types. One is potential energy and other is kinetic energy. Now today we are discussing about kinetic energy, so we will mainly focus on this kinetic energy. It is due to the motion. The other form, the potential energy, it is due to the position or the shape of the body. So but today we are going towards kinetic energy, which is due to the motion of the body. So first of all, you have defined it, you will get 1 mark for this definition. Then you need to give an example. You can give an example from our daily life, like whenever a car is moving, then it means it must have kinetic energy. The third thing, that is its formula. So we have decided that we will denote this term by Ke. So I wrote Ke here, 1 over 2 mv square, half mv square. This V is showing that the kinetic energy is related to motion or the velocity of the body. Whenever the body moves, it must have kinetic energy. Then the main thing is that you need to derive it. As in long question, you need to derive it. You can see in the past papers that it has been asked many times as a long question and also as a short question. So now we are going to discuss about its derivation. So in any derivation, first of all, you need to assume something. We need to take something to derive it, to make the foundation, to make the base of the derivation. We will consider a mass which is moving with velocity v. Moving with velocity v means its initial velocity is v, and after some distance, as you know that the symbol of distance is s, body stops. Body stops mean it is going to in the form of rest due to some opposing force such as friction. Here we are going to take friction as opposing force. Whenever the things are stopped, they are stopped due to some opposing force. So we can take an example of a car. If you need to stop the car, you need to apply some brakes. So brakes will be the opposing force, and this opposing force, the brakes will get from the friction between tires and the road. So the body possesses kinetic energy and capable to do work against the friction. Here we are going to discuss about the kinetic energy. So this kinetic energy is the work done against the friction. So from this assumption, I'm going to make an equation. Kinetic energy of the body is equal to work done by due to its motion. Motion against work done by a body due to its motion against the friction. So Ke is equal to Fs. Fs, you know that it's a formula of work done. Formula of work done is Fs. So I denoted kinetic energy as Ke. So and the work done is Fs. We have assumed that body is moving with velocity v. So its initial velocity will be v. And after covering some distance, body stops due to some opposing force such as friction. So body is going to stop. So it means its final velocity will be 0, because stop means there is no velocity. So we have taken two things from there, or assumption that initial velocity is v and final velocity is 0. The third thing, we are talking about the opposing force, so there must be some force here. So according to the Newton's second law of motion, we know that F is equal to ma. This is according to Newton's second law. As it is an opposing force, so it must be in opposite direction of the motion of the body. So we want to show it the opposite force, so we will take it as minus ma. This minus sign shows that this is an opposition, this is an opposing force. So here this minus sign is showing that the body is the force which is implementing on the body is negative or opposite sided. So after rearranging it, we will get A is equal to minus mf over m. Look, till now we are just making the foundation for our derivation. As you know that kinetic energy is equal to half mv square, and we are approaching towards kinetic energy is equal to half mv square. So from our assumption, we need to use some equation of motion to prove it. So here I am going to use third equation of motion, 2as is equal to vf square minus vi square. Why I am going to use it? Because I have acceleration, I have the knowledge of acceleration, I have the knowledge of distance, I have the knowledge of vf, and I have the knowledge of vi. So now I am just going to put all these values into this equation, and we will be in our concluding position. Look, from the previous assumptions I came to know that A is equal to minus f over m. So I put minus f over m in the replacement of A. S will remain same because in our assumption we have decided that the distance is s, final velocity is 0 and initial velocity is v. So I put all these things into this equation. So after rearranging this equation, this will be like this: minus 2fs is equal to minus mv square. You know that this m will be going towards this side and it will become minus mv square. 0 stands for nothing. Then after rearranging more, you know that this negative sign will cut from this negative sign. This 2 is multiplying here, it could be here in the form of division. So 2 is multiplying here, it will be divided, it is going to divide on the other side. So we have already decided that work done is equal to kinetic energy. So we have proved that kinetic energy is equal to half mv square. So that's the question we just discussed about it, and it could be asked in both ways, either in short question or long question, as I have told you earlier. So according to the asking of the question, you need to give your answer. In short question, it could be asked in such a way that define kinetic energy and give its formula. Then you just need to define it and give its formula. It could be asked in such a way that define kinetic energy, give its an example. You just define it and give it an example. And if in a long question, it could be asked like define kinetic energy and derive its relation. That we have done all the thing today in today's class. You can prepare it and get good marks in your exam. So wish you best of luck for your exam. Prepare for the exam, for the board exams, and get good marks. Allah Hafiz.